So what we're talking about is how to prove triangles are congruent. And there are a couple of theorems we can use. One we're going to postpone till later. But side, side, side is the primary. It says that if I've got a pair of sides that are congruent and another pair of sides that are congruent and a third pair of sides that are congruent, then those two triangles are completely identical. They are congruent in every way. The side angle side says that I've got a side, I've got a second side, and the angle is trapped in between side angle side, side angle side. Angle side angle is where I've got two angles, but the side trapped in between is the part that's congruent. An angle angle side again has two angles, but this time the side is not trapped in between it. 5, I think I understand those. The Mario Kart analogy gave me what I need. I can roll from there. 3, I need a little more application to see how these are used, but I think I'm sort of getting it. 1, I don't understand how to distinguish ASA from AAS. Okay, good. I'm going to come back to HL later. I'm going to come back to these later today, and I do want to talk about this. If in fact we prove that two triangles are congruent, for example, we prove that ABC, triangle ABC, is congruent to triangle DEF. It could be that, for instance, I had angle A is congruent to angle D, and I had AB is congruent to DE, and I needed a third piece of information to make those congruent. What is the possible third piece of information I could have? Let's do it this way. What if I had to use angle side angle? What's the third piece of information I would need? I'd need B and E, right? Because then I'd have angle side angle, angle side angle. What if I had to use angle angle side? C and F would have to be congruent, right? What if I had to use side angle side? A, C, and DF, good. Is it possible that that third piece of information that would be enough for me to prove the triangles are congruent would be BC and EF? It would be a third piece of information, but then I would have angle, side, side. Angle, side, side, which is not one of the ones we listed here. And in the video, I think I talked about how, ooh, that's not something we're allowed to say in math. It's going to help us remember not to use that. But however it is that I go about proving this, let's pretend that I have these pieces of information. However it is that I go about proving these two triangles are congruent, I can create what's called a triangle congruence statement. And let's say that I say triangle BCA. I'm talking about the triangle made up of B and C and A. That triangle is now congruent to this triangle, but I have to name it in a certain way. B corresponds to which letter over here? E, right? They both are marked the same way. So if I start with B here, I have to start with E there. Then I'm traveling to C. C is the angle that's not marked as congruent. So what angle corresponds to that here? F. So BCA would be EFD as a corresponding triangle. And it's really important that we write it that way, because then the corresponding parts all line up. If I want to find out, for instance, side BC, I could say that side BC is congruent to what side? EF. And I could say side CA is congruent to what side? FD, right? CA are the last two letters here, so I'd use the last two letters here, FD. What if I said I wanted to see what DE is congruent to? Good, AB. And I can do it with just angles too. What if I said I want to see what angle C is congruent to? Good. And angle D is congruent to angle, yep. And angle E is congruent to B. This is called a triangle congruence statement. And it's really important because it demonstrates that if the two triangles are congruent, that every corresponding part is also congruent. We do have a theorem that we'll use today called CPCTC. Stands for corresponding parts of congruent triangles are congruent. Let you get that copied down. Okay, flip to the second page, please. These next two pages are going to be very simple proofs. Like, so simple you will be insulted. I'm sorry about that. We've got our two columns already made up for us. For those of you that are online, if you don't have access to a printer, what I've done is these documents are editable so that you can actually type the letters in Google Slide. So if you don't have access to a printer, you can still take notes as we go forward. For this first one, I'm going to take my givens and I'm going to enter them here. So I'm going to say AB is congruent to DE, and that's a given fact. And then I'll take BC is congruent to EF, and that's a given fact. And then I'll take angle B is congruent to angle E, and that's a given fact. Now the question is that enough to prove the triangles are congruent? That's what I'm going for. It's hard for me to tell from the way I've written it. So I strongly urge you, once you put the information into the table, to then draw it on your picture. AB and DE. So I'll put a mark on AB and a mark on DE. Then I want BC, it's a different mark, so 2 hash marks, and EF. And then I want angle B and angle E. Having now annotated the picture, what's the Mario Kart name that goes with this? Side angle side. Excellent. And is side angle side one of the ones that we use to prove congruence? It sure is. Therefore, we can say that triangle ABC is congruent to triangle DEF. It's aligned correctly. And our reason is just going to be SAS. QED, we're done. That's all this proof is requiring of us. Let's try number 2. Enter the givens. As we enter the givens, I'm going to write on my picture what marks it makes. Angle C is congruent to angle F. It's given. So C and F angles are the same. I know this is kind of cut off, but that's B and E. Given. And I have to use a different mark to show that B and E are congruent, but not the same as C and F. And so I ask myself, do I have my 3 pieces of information? Are they the right 3 pieces of information? What does Mario Kart say these should be called? Angle, angle, side. Is that one of our ones that works? Yes, it is. Therefore, I can say that triangle ABC is congruent to triangle DEF by angle, angle, side. That's all I was asked to do. I did it. So QED. 5. Okay, this does seem ridiculously easy. 3. Yeah, I know you. It's going to get harder, but I can do this part. 1. I don't get this. Okay, good. All right, please do number 3 and 4 yourselves now. Okay, I've added in the givens and I've annotated my picture to match. Number 3 is congruent by what theorem? What Mario Kart name do we give this? Side, 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 or SSS.
Whoa. Number 3 is an angle sign.
Down here it did? Yeah, but I had to write over that. That was a mistake because the only givens I had were givens as sides. Sorry about that. What about number 4? As I annotate these pieces, what do I call this step? Angle, side, angle, ASA. Any questions on these 4? Very straightforward, super logical, not much creativity yet. Flip to page 2. Same idea. I'll leave numbers 5, 6, 7, and 8 for you guys to do. They are exactly the same concept. But let's go down to number 9 for a second. Start the same way. We're going to enter in our givens. BA is congruent to CD, and the reason is given. And I'm going to mark that as I put it in. B is congruent to C, given, and I'll mark it. But this time I've only got 2 givens. So there's going to be a third given. Well, it's not really given, but it's there in the picture. It's somewhere in there in a way that will work for us. It's a piece of information that's true. We can say with certainty. And what you'll find on your front page is to find that third piece of information. If it's a side, it's usually going to be the definition of midpoint or reflexive property. In other words, it's a side that's shared by both. And if it's congruent angles, it could be vertical angles, some of our parallel line stuff, angle bisectors. It also could be reflexive, but it would have to be overlapping. I think Josephina saw this. What do you think is the third piece of information here? Vertical angles, good. So what do we call these angles here? Good. You recognize we can't call them angle X, right? That's not specific enough. I can't tell which angle I'm talking about if I were to call them angle X. But I can say that angle BXA is congruent to angle CXD. And what's my reason for that? Yeah, in other words, I'll write it as an if-then statement that we've used so much. If it's a vertical angle pair, then it's congruent. BXA and CXD. These 2 yellow ones. Oh, again, that's why it's so important the way we write it, isn't it? Because BAX is a totally different angle than BXA. Now, this whole proof and any proof is supposed to be a logic chain. And so if I'm saying if they're vertical, then they're congruent, then it requires that my prior step says that they are vertical angles. So I left room here so that I could say angle BXA and angle CXD are vertical angles. And if they're vertical angles, then they're congruent. The reason I call them vertical angles, any guesses? Very good. Definition of vertical angles. They're called that because that's their name.
If you put VXA and two angle symbols,
Here,
yeah,
I've got an and symbol and then angle CXD. And now that I can mark those vertical angles in my picture, I can think about the Mario Kart analogy. These triangles are congruent by what? Angle, angle, side, right? Now, this one is more typical of what you'll see in writing proofs. You'll be given most of the information, but you'll need to use a little bit of your own knowledge to do some of it. So if you flip the page again, you'll see this is a whole page of proofs. There are 12 of them. And the page after this, I've effectively made an answer sheet for you. So you can tear it off and you don't have to write out all of the little tables. So in this first one, we'd take the three givens and then we'd write the prove and we write SAS. So I did this first one completely for you. The second one, we're given two pieces of information. We can enter those in. We then recognize that vertical angles are the third piece. So we'd say they are vertical angles, definition, and then we'd say they're congruent. And my font's changed here. Please change this @ symbol to a congruent symbol. And then once we do that, we could say that these two triangles are congruent by what? Good. Angle, side, angle. Take a look at proof number 3. And this one has not been annotated yet. So as we write in YF is congruent to NY, put the marks on there. UF is congruent to UN, put the marks on there. We've only got two pieces of information, so we need to find a third one. There's no vertical angles this time. And on the answer sheet, I show you that it's YU equals YU. So we know it's going to be these things marked congruent. But why is that true? Say again? Angle bisector, but I don't see the words angle bisector. And if it said angle bisector, then I would expect this angle and this angle to be the same. What we're trying to say is this segment is the same. Donovan?
I have a super awkward question.
Can you hold that? Hold that until we get through this. Yeah. Excellent. It is reflexive property. Remember last semester, we talked about reflexive property like A equals A and B equals B, and you just didn't know what value it has. This is the value. This is why we learned it. When YU is equal to YU, that is the reflexive property. In other words, those two segments, the YU for the top triangle and the YU for the bottom triangle, they're the same segment. So of course they're the same length. And with those three pieces in place, I can now say these two triangles are congruent by what? Side, side, side. Okay, Donovan, take us off task.
Okay, so at the end of does our year and final have things from the first semester?
The year-end final will focus on material from the spring semester.
Okay.
However, there are some components like reflexive
Yeah.
that we learned in the fall
Yeah.
that are part of the spring.
Okay.
So it won't focus on things from the fall. Like I wouldn't ask you to do transformations, for example.
Yeah.
But all the knowledge that you picked up is kind of relevant to going forward. Does that make sense?
Yeah, I was just wondering, like, is it like a year and final? Or like
No, it's really a semester final, but the content is kind of cumulative. Yep. Okay. All right, let's go to number 7. Take a look at number 7, please. Given AB is DC. So I'm going to fold my paper a little bit so I can put these both on the same screen. AB is congruent to DC given. And when I write it here, I draw it on my picture. And then angle ABC is DCB. Angle ABC is the same as angle DCB. I need a third fact. How many people think they see the third fact? Yeah, not a lot. So what I'm going to do is I'm going to suggest that we identify what we're going for here. We're trying to prove angle ACB. ACB. That's one of the triangles. Is congruent to triangle DBC. I do find that by drawing in with highlighters, it helps me. Couple of hands. Price, what do you see? Okay, it is a reflection. I see what you're saying. And that makes us think that they probably are congruent. But we still need that third fact. BD? BC, good. BC is a segment along ABC, and it's also a segment along DCB. Therefore, it's a shared side. So I can say BC is congruent to BC, and that gets one from the yellow triangle, one from the orange triangle. But my reason is what? Good, reflexive.
Wait, are you saying line BC is congruent to line BC?
Yep. Property of congruence, right? And are those 3 pieces of information enough for me to see it? Sometimes I'll tell you that sometimes it's really hard to see. And what you might need to do is separate the triangles out. Draw them again with the marks in place. And then it's easier for you to see. What's the Mario Kart analogy saying why these are congruent? Side angle side. And done. Okay, last one I'm going to do for you. And then I'll set you off to go do this stuff yourself. Number 11. Let's start the same way. We got some givens. Oops. And then RS equals PS. What's next?
Yeah, Josh?
Does it have to be angle SI
SRE is congruent to angle SCP vertical angles.
You're right that it's angles, you're right that it's vertical angles, but you named them incorrectly. When you said SRE, you're describing this angle up here. RSE, good. So we're going to want to say angle RSE and angle, let's see, this one's unmarked. So we started at P. PSU are vertical angles. That's definition of vertical angles. And that lets us then say that angle RSE is congruent to angle PSU because vertical angles mean congruent. Very good. And with that in place, I can draw that in. Do I have enough to prove the triangles are congruent? I do. So let's say we want to call this triangle first. What do we call it? How do we name it? Triangle RSE? Sure, first one's free. But now that I've determined that it's RSE, I have to name the second triangle in the right way. What is it? Well, that would suggest that U and R are aligned. PSU, good. So RSE is congruent to PSU, and that's because of what? Angle, angle, side. But wait a minute. What am I trying to prove here? You know where it says prove? It doesn't say prove the triangles are congruent. It's a little different, isn't it? This is that CPCTC thing. Yep, just one more line. There should be a line over the top. Once we say that the triangles are congruent, we can then easily move on to say, oh, that means that any corresponding parts are congruent by CPCTC. Remember this? Okay, keep playing with this for a second. We'll be right back.
Oh.
I don't know. The other ones are always like, I haven't played. What? Oh yeah, yeah. Next year. Not this year.
That's right. We don't call it. Yeah. So what's the point of doing it in like a way like this, like the Mario Kart? It's like alpha.
But it's only taking,
Because I can just look at this, right? Say, if you want to move one side,
that's taking on the side.
that's not alphabetical.
So when I say alphabetical, what I mean is all the choices of two letters, A's and S's.
Yeah.
I can have AAA, AAS, ASA, ASAA.
You can have a.
These are just terms of possibilities.
Okay, yeah.
Right? And then I can have two S's, like the SSA, I can have SAS, I can have ASS, or I could have three S's. So these are all the possibilities of A's and S's. And what we've decided is that this one does not prove triangles congruent,
Yeah.
and this one does not prove triangles congruent.
Yeah.
This one and this one are the same thing. They're just flip versions of each other.
Okay.
That's when I say alphabetical. Instead of calling it SSA, which is the same as this, just in a mirror, we're going to use this name. So we'll never use that one anyway. And similarly, this one and this one are the same. They're flipped versions of each other.
Huh? I don't know. It's kind of like a lot.
It is a lot. I agree.
Like, there's a lot of just like A's and F's.
Yeah. It'll come with more practice. I know that this is a really kernel part of geometry. It's a really important part.
Well, that's not going to be good.
Well, it is good to hear because you want to recognize this is not the one you just let blow by. Yeah, you look around, lots of those videos are good for you too. Oh, yeah. You're good. If you're gonna blow up something, just go on to it. You can blow it up with new ones. Okay.